Okay, this is Unit 13, Lesson 2. This is about the shaded areas involving circles. Okay, this video, our lesson, if you've got any kind of idea that you might need to ask a question about something, get yourself a piece of paper and a pen or pencil so that you can record that to bring it to class with you tomorrow. Okay, so let's take a look and see what we've got here. With the definitions as such, simply this: in engineering and technology, it is often necessary to find shaded areas in which some shapes are inside other shapes. In these cases, you find the area of the large object and find the area of the small object and subtract the small object from the large object. That's what it comes down to. So subtraction of areas is generally involved, as is illustrated in the following examples and problems. Okay, so example 1, they want us to find the shaded area by subtracting the area of the inscribed circle from the area of the square. Okay, so what we do is we take a look at our diagram. We notice that the circle is inside the square, so this means the area of the square will be larger than the area of the circle. So what we have to do is find the area of the square and subtract the area of the circle from it. The square is going to be easy because we know one side of the square is 14 centimeters, so we just simply square the 14, which gives us the area of the square. We need to find the radius of the circle, however, because the diameter of the circle is going to be equal to the length of the side of the square, which is 14 centimeters. So the radius is simply going to be the diameter, which is 14, divided by 2, gives us 7 centimeters for the radius. So this allows us to set up what we're looking for. The shaded area is going to be given to us by the area of the square minus the area of the circle. So the shaded area is equal to 14 squared minus pi times the radius 7 squared, which gives us 196 minus 49 pi is approximately equal to 42.06 square centimeters. Okay, example 2, they want us to find the shaded area by subtracting the area of the isosceles trapezoid from the area of the circle. The shorter base of the trapezoid is 12 inches, the longer base is 18 inches. The longer base also happens to go through the center of the circle and from side to side, so it's also the diameter of the circle. So the height of the trapezoid, they tell us, is 6.7 inches. So here's what we have. We got this situation here. So we got to find the area of the trapezoid to subtract that from the area of the circle, which is larger in this case. So the area of the trapezoid, if you remember, is 1/2 of the two bases added together times the height, which is 6.7 in this case. So that gives us an area of the trapezoid is approximately 100, or is actually 100.5. Okay, so the area of the circle, we calculate that by using pi times the radius squared. Since the diameter is 18 that we talked about earlier, because that's the base of the trapezoid that goes through the center of the circle and from side to side of the circle. So that gives us 9 for the radius, and 9 squared is 81. So 81 pi is the exact area of the circle, which approximates out to 254.47. Okay, so we're going to find the shaded area by subtracting the area of the trapezoid from the area of the circle. So this gives us that the shaded area is approximately 254.47 minus 100.5, which comes out to a net of 153.97 square inches. Okay, this concludes Unit 13, Lesson 2. So if you've got any questions, make sure you've got them written down. If you've neglected to do so and you now have a question, go back and watch the video again, find the part that you had a problem with, and record your question. Okay? Thank you very much. We'll see you in class.